Hey kids, Miss Kulkarni here. In this video, let's talk about nuclear reaction. So, nuclear reactions are always different than chemical reactions. What are the main differences? In chemical reactions, atoms are rearranged and the products are nothing but new substances formed after this rearrangement. About the energy change, those are always small in chemical reactions. And what actually initiates a chemical reaction? That is the valence electrons. Now, in nuclear reactions, the main change is because of either number of protons or neutrons. What is the product? The product could be a different isotope or it could be a totally different new element. And then how about the energy? The energy changes are huge. And there are mainly two types of reactions, fission and fusion. And we will discuss that later in this video. So there we go. A fission is when we have a heavy nucleus divides into two or more smaller but stable nuclei. Of course, the energy is going to be large amount of energy. The process could be spontaneous and also it can be caused when we bombard the nucleus with some other particles. The process will continue and that's why this results in chain reaction. Now what happens when the chain reactions are not controlled? In that case, it may result in explosions. And this principle is actually used in atomic bombs. Whereas the controlled chain reactions are extremely useful and they are used in nuclear power plants. This is one of the alternate source of energy that we are considering. So, the controlled chain reactions, how do they work and how do they produce the energy? These create energy that results into heating water first. Of course, water will produce steam. Then steam will power the turbines and turbine is connected to a generator which will produce the electricity. So that's the cycle by which a nuclear energy could be converted into the electrical energy. So as you notice, the process runs into cycle and we can end up having electrical energy from nuclear reactions if we control them. Now, in order for us to control these nuclear reactions, there are some precautions. One of them is we use lead and concrete structures to make sure the radiations will not escape. Also, the reactions may generate a lot of heat, so we have water cooling systems around the reactant. And also, there is something called control rods, mostly they are cadmium rods, which will absorb the neutrons. So, it will kind of control the chain reactions and avoid them by being without any control. So, what is the big advantage of nuclear energy? Number one, there is not going to be any air pollution which we normally get with any other fuel. Also, there will be a lot of energy when we have tiny little fuel. What about the disadvantage? Even though we take precaution, there is still the risk for accidents and maybe explosions. Also, the disposal is a big problem for nuclear waste. And then over here, this will tell you the process when nuclear energy is converted to electrical. First, from nuclear energy, it goes to thermal when we use it for heating and boiling water to convert it into steam. Then that is connected to turbines, so that becomes mechanical, and from turbines it goes to electrical energy. Let's talk more about nuclear fission. We can also name these nuclear fissions as radioactive decay because slowly the amount keeps on decreasing, just like any substance will start decaying. Apart from energy, They also release some radiations, and those are gamma radiations. Now, if there is a long-term exposure to the radiations, it can cause some dangerous diseases like cancer or even DNA mutations. So working in nuclear plant could be a little bit more riskier. Now, which are the elements which are prone to be radioactive? Those are all elements which we call as heavy elements, and those are anything beyond bismuth. Bismuth is atomic number 83, and anything above that will be large, and if it's large, then they will be unstable. Sometimes elements also can undergo fission reactions. Those are the elements when the number of neutrons is greatly different than number of protons. There's a huge gap. That makes it unstable, and most likely they are going to decay to become stable. So whenever these unstable elements, they undergo the changes, they change their identity, and we call them as if those are transmutations process. Now let's talk about nuclear fusion. And in this process, we have two or more light nuclei. They join to form one larger nucleus. Again, the energy is going to be huge. Also, there could be extremely high temperatures and pressures required to have effective fusion. One of the examples of nuclear fusion is the energy released in stars, including sun. What happens there? There are uncontrolled fusion of heavy hydrogen, and they constantly cause explosions. That's what actually is the principle behind hydrogen bombs. Now let's talk about particles that are lost or gained by radioactive atoms. One of them is alpha particle. We call it as alpha decay or alpha emission. And these are nothing but simply helium nucleus, which we represent as helium atom with atomic mass number 4 and atomic number 2. We can also denote that with a sign alpha. And these are the one which are slow moving particles. They can be easily stopped just by holding a paper in front of them. The second type of particles are beta particles, and we again call this as beta decay or beta emission. Beta particles are nothing but simply electrons, and we represent those in this fashion, or we can also use beta as a symbol. Beta particles are little faster than alpha particles, but they can be blocked by either wood or a piece of glass. The third type of particles are positron, just like positive electrons, and these can be represented similar to electrons except the charge is positive 1, or we can also write down beta with positive plus charge. Positrons are also faster than alpha particles, and they can be blocked by wood or glass. Now some particles may be actually captured. So we have a process electron or beta capture, in which an electron could be gained. And now one final radiation, which is gamma radiations. These have no mass or no charge. They are simply electromagnetic waves, but they have a lot of energy. So most of the nuclear reaction will always release some amount of gamma radiations. Because they have no mass, gamma radiations, they can penetrate almost all the substances. But there is one substance that can block gamma radiation, and that is lead. So in this picture, you can see how can we block alpha, beta and gamma particles. Alpha particles can be blocked by paper, beta particles can be blocked by wood or glass, and if it's gamma particle, they can be blocked by lead. So I guess that gives you a fair idea about nuclear reactions. I hope you guys enjoyed the video. and I will see you again in next video. Until then, bye bye.